Earth, as big as it feels to us, is basically a tiny wet pebble floating around the sun with confidence it did not earn. Earth is about 93 million miles away from the sun, which sounds like a lot until you realize light makes that trip in about 8 minutes, meaning sunlight is technically old news by the time it hits your face. Every time you stand outside and say, "Wow, the sun feels nice," you are reacting to something the sun did 8 minutes ago. Now, Earth is part of the solar system, which is our local space neighborhood, and just like most neighborhoods, it has a few nice places, a few terrifying places, and one giant gas planet that looks like it should be investigated. The solar system has 8 planets, a bunch of moons, asteroids, comets, dwarf planets, and Pluto, who is still hanging around after being demoted like an employee who refuses to leave the group chat. The farthest official planet, Neptune, is so far away that sunlight takes a little over 4 hours to reach it. So if the sun suddenly disappeared, which would be rude, Earth would find out in 8 minutes, but Neptune would be sitting there for hours, like everything was fine. And even after Neptune, the solar system does not just stop. It keeps going into regions filled with icy objects, scattered debris, and distant leftovers from when the solar system was being built. Eventually, you get to the outer edge of the sun's influence, where the solar system fades into interstellar space, and by this point, we are already dealing with distances so large that miles become annoying. This is why astronomers use light years, because if they kept using miles, every space documentary would just be a man reading zeros. A light year is not a measurement of time, even though it sounds like one, because of course astronomy would do that. A light year is the distance light travels in 1 year, and light moves at about 186,000 miles per second. That means 1 light year is about 5.88 trillion miles. Not billion, trillion, with a T. The kind of number that makes your bank account look like it was written as a prank. So instead of saying something is 30 trillion miles away, scientists just say it is about 5 light years away, which sounds much nicer, even though it is still absolutely insane. The closest star system to us is Alpha Centauri, a little over 4 light years away, which means the light we see from it tonight started traveling toward us more than 4 years ago. You are not looking at Alpha Centauri as it is right now. You're looking at Alpha Centauri from the past. Space is basically a giant delayed live stream with no comment section, which is probably for the best. Now, 4 light years is already hard to imagine, but that is just the closest neighboring star system. That is the house next door. And by next door, I mean if your neighbor lives so far away that even going there at the fastest speed humans have ever sent a spacecraft would take tens of thousands of years. This is where the universe starts getting disrespectful, because our sun is not special in the way we usually want things to be special. It is one star among hundreds of billions of stars inside the Milky Way galaxy. The Milky Way is our galaxy, and it is about 100,000 light years wide. That means if you could travel at the speed of light, which you cannot, because physics has boundaries and does not care about your goals, it would still take you around 100,000 years to cross from one side of the galaxy to the other. For perspective, humans have only had cities for around 10,000 years. So if someone started traveling across the Milky Way at light speed back when humans were figuring out farming, they would still be nowhere near done. They would probably be bored, insane, and somehow still looking for a bathroom. And inside this galaxy are at least 100 billion stars, possibly hundreds of billions. And around those stars are planets, moons, asteroids, dead rocks, giant gas worlds, frozen worlds, lava worlds, and probably at least one planet where something has invented taxes and is also upset about it. When you look up at the night sky, almost every star you see with your naked eye is still inside the Milky Way. That entire sky that feels endless to us is mostly just our local galaxy showing off. And the most annoying part is that we cannot even see the whole Milky Way properly from the inside, because we live in it. Trying to see the full shape of the Milky Way from Earth is like trying to see what your house looks like from the outside while standing in the laundry room. You can make some educated guesses, but mostly you're surrounded by dust, walls, and things you forgot to put away. So already we have gone from your room, to Earth, to the solar system, to nearby stars, to the entire Milky Way. And you may think, okay, that must be the big thing. That must be the universe. And unfortunately, no. The Milky Way is not the universe. The Milky Way is just one galaxy. A very large galaxy to us, sure. But in the universe, it is basically one glowing island in an ocean so big that calling it an ocean feels disrespectful to oceans. Our nearest major galaxy neighbor is Andromeda, and Andromeda is about 2.5 million light years away. This means the light from Andromeda takes 2.5 million years to reach us. So when you see Andromeda in the sky, you are seeing it as it looked before modern humans had even shown up to complain about Wi-Fi. That light left Andromeda while ancient human ancestors were walking around Earth, probably looking confused and trying not to get eaten by something with better teeth. Andromeda itself is also enormous, with around 1 trillion stars, because apparently it saw the Milky Way and decided to be extra. And the Milky Way and Andromeda are both part of something called the local group, which is a small collection of galaxies held together by gravity. And when I say small, I mean small by universe standards, which means it is still stupidly large. The local group contains the Milky Way, Andromeda, the Triangulum Galaxy, and a bunch of smaller dwarf galaxies orbiting around like tiny cosmic side characters. Some of these dwarf galaxies are still huge by human standards, but next to the Milky Way and Andromeda, they look like they are trying their best. Now, the local group is not floating around alone either. It is part of a larger structure connected to even bigger galaxy collections, including the Virgo supercluster and the even larger Laniakea supercluster. These superclusters are massive networks of galaxies, spread across tens or hundreds of millions of light years. And they are not arranged randomly like someone spilled glitter in the dark. The universe has structure. Galaxies collect into groups, groups collect into clusters, clusters connect into superclusters, and superclusters form long cosmic filaments, like glowing threads stretched across the universe. Between those filaments are enormous empty regions called cosmic voids, where there are very few galaxies at all. These voids can be hundreds of millions of light years across, which means there are parts of the universe where almost nothing is happening for a distance so large that the Milky Way would look like a crumb. No stars nearby, no planets, no moons, no gas station, no McDonald's, nothing. Just darkness and space, and probably enough silence to make even an introvert start looking for plans. And here is where the scale becomes very hard to keep gentle, because all of that, the solar system, the Milky Way, Andromeda, galaxy groups, galaxy clusters, superclusters, cosmic webs, and huge empty voids, is still only part of the observable universe. The observable universe is the part of the universe we can see, not because our telescopes are lazy, but because light has a speed limit. The universe is about 13.8 billion years old, so light from extremely distant places has only had 13.8 billion years to reach us. But because space itself has been expanding during the time, the farthest things we can observe are now much farther away than 13.8 billion light years. This is the part where the universe starts acting like it is trying to win an argument. The observable universe is about 93 billion light years across. That means from one edge of what we can observe to the other edge is roughly 93 billion light years. And remember, one light year is already about 5.88 trillion miles. So if you want to convert the observable universe into miles, that number would be so large it would look less like a measurement and more like your keyboard had a seizure. The observable universe is not a ball with Earth at the special center of everything, by the way. It only looks that way from our perspective. Every observer, anywhere in the universe, has their own observable bubble, because they can only see the light that has had time to reach them. So Earth is not the center of the universe. It is just the center of what we personally can observe, which is exactly the kind of technicality humans would absolutely take too seriously if the universe let us. Inside the observable universe, scientists estimate there may be hundreds of billions to trillions of galaxies, and each galaxy can have millions, billions, or even trillions of stars. And many of those stars may have planets. So when people say there may be more planets in the observable universe than grains of sand on Earth, they are not trying to be poetic. They are trying to explain a number so large that your brain refuses to accept delivery. Think about one beach, then every desert, then every grain of sand on Earth. Now imagine each grain is a planet, except the universe may still have more. And on each one of those planets, there could be nothing, or rocks, or storms, or oceans, or frozen wastelands, or some weird creature staring at its own sky, wondering if anyone else is out there, while also probably avoiding chores. The scale is not just large in one direction, it is large everywhere. There's no obvious edge in the part we can study. Space expands in all directions. Galaxies are moving away from each other as the universe stretches, like raisins in bread dough, which is a common science analogy, except now I have made the universe sound like a giant baked good that is still easier to understand than dark energy. The farther away a galaxy is, the faster it appears to be moving away from us, not because it is flying through space like it has somewhere to be, but because space between us and that galaxy is expanding. This is why the observable universe has a horizon, not a wall, not a glass dome, not the part where the loading screen ends. A horizon, just like on Earth, where you can only see so far before the curve of the planet hides the rest. In space, we can only see as far as light has had time to travel to us. Beyond that cosmic horizon, there could be much more universe, maybe a lot more, maybe infinitely more. We do not know. And that is the part that quietly ruins your day if you think about it too long. Because the observable universe, the 93 billion light-year wide bubble, with hundreds of billions or trillions of galaxies inside it, may not be the whole universe. It may just be the part we are able to see. The actual universe could be far larger. It could go on forever. It could have regions so far away that their light will never reach us, no matter how long we wait, because space is expanding too fast between us and them. That means there may be galaxies, stars, planets, and entire cosmic histories that are real, but permanently outside our view, not hidden behind a curtain, not waiting for better technology, just unreachable. The universe basically has a privacy setting, and what makes this even stranger is that when we look far away, we are also looking back in time. Telescopes are time machines, but not the fun kind where you can go back and stop yourself from making a bad haircut decision. When a telescope looks at a galaxy 1 billion light years away, it sees that galaxy as it looked 1 billion years ago, because the light took that long to get here. When we look at some of the farthest galaxies, we are seeing them as they existed when the universe was young. So the night sky is not showing us the universe as it is right now. It is showing us layers of history. Nearby stars are recent. Distant galaxies are ancient. The farther out you look, the deeper into the past you go, which means space is not just big in distance, it is big in time. The universe is a giant museum where every exhibit is also moving away from you, aging, exploding, forming stars, dying, and refusing to explain itself in a simple way. And even with all of this, we still have not talked about the tiny fact that most of the universe is not even the normal stuff we understand. The stars, planets, people, pizza, oceans, asteroids, and everything made of atoms only make up a small part of what is out there. Most of the universe appears to be dark matter and dark energy, which are names scientists use for things they know are affecting the universe but do not fully understand yet. That is not an insult to scientists. That is just how big and strange the problem is. Imagine cleaning your room and realizing 95% of the mess is invisible. That is basically cosmology. We can map galaxies, measure light, study radiation from the early universe, watch stars explode, detect black holes, and still the universe is like, that is cute, but you are missing most of it. So how big is the universe? The honest answer is, the part we can see is about 93 billion light years across, and the whole thing may be much bigger, possibly infinite, which is a very science way of saying, we measured the room, but we are not sure if the building ever ends. And if that makes you feel small, that is normal. You are small, I am small, Earth is small, the sun is small compared to other stars. The solar system is small compared to the Milky Way. The Milky Way is small compared to the local group. The local group is small compared to superclusters. Superclusters are small compared to the observable universe. And the observable universe may be small compared to the actual universe. At this point, being small is not an insult. It is just the price of living in a reality that went completely overboard. But here's the weirdly comforting part. Even though the universe is ridiculously huge, we can still understand pieces of it. We can measure the distance to stars. We can figure out how galaxies move. We can look at ancient light from billions of years ago. We can know that Andromeda is coming toward the Milky Way, that the universe is expanding, that light has a speed limit, and that the observable universe has a horizon. A tiny species on a small planet around an average star somehow built tools powerful enough to look across billions of light years and say, yeah, that fuzzy dot is a galaxy from near the beginning of time. Which is insane. Most of us cannot find the TV remote while standing in the same room as it, but as a species, we can measure the age of the universe. So maybe the size of the universe is not scary because it makes us feel meaningless? Maybe it is scary because it shows us how much reality exists outside our daily problems. Your bills, your texts, your awkward memories from middle school, all of it is happening on one tiny planet in one solar system in one galaxy inside a universe so large that light itself needs billions of years to cross parts of it. And yet, somehow, your brain can still sit here and imagine it. Not perfectly, not without overheating a little, but enough to feel the scale. Enough to realize that every star might have worlds, every galaxy might have stories, and everything we know is sitting inside something so large that the word large gave up 5 paragraphs ago. So the next time you look up at the night sky, just remember, you are not looking at a ceiling. You are looking into a universe so big that even the part we can see is already too much for a normal human brain, and the part we cannot see might be bigger still. And if that starts to make your head hurt, do not worry. That is not your brain failing. That is just the universe being rude.